The Boeing YAL-1 Airborne Laser Testbed, formerly Airborne Laser, weapons system was a megawatt-class chemical oxygen iodine laser coil mounted inside a modified military aircraft Boeing 747-400F. It was primarily designed as a missile defense system to destroy tactical ballistic missiles (TBMs) while in the boost phase. The aircraft was designated YAL-1A in 2004 by the U.S. Department of Defense. The YAL-1 with a low-power laser was test-fired in flight at an airborne target in 2007. A high-energy laser was used to intercept a test target in January 2010, and the following month, successfully destroyed 2 test missiles. Funding for the program was cut in 2010, and the program was cancelled in December 2011. It made its final flight on February 14, 2011, to Davis-Monthan Air Force Base in Tucson, Arizona, to be kept in storage at the Boneyard by the 309th Aerospace Maintenance Regeneration Group. It was ultimately scrapped in September 2014 after all usable parts were removed. The Airborne Laser Laboratory was a less powerful prototype installed in a Boeing NKC-135A. It shot down several missiles in tests conducted in the 1980s. The U.S. Air Force initiated the Airborne Laser program in 1996 with the awarding of a Product Definition Risk Reduction contract to Boeing's ABL team. In 2001, the program was transferred to the MDA and converted to an acquisition program. A team of contractors was accomplishing the development of the system. Boeing Defense, Space and Security provides the aircraft, the management team, and the system's integration processes. Northrop Grumman supplies the coil, and Lockheed Martin supplies the nose turret and the fire control system. In 2001, a retired Air India 747-200 was acquired by the Air Force and trucked without its wings from the Mojave Airport to Edwards Air Force Base, where the airframe was incorporated into the System Integration Laboratory (SIL) building at Edwards Burke Flight Test Center, to be used to fit, check and test the various components. The SIL was built primarily to test the coil at a simulated operational altitude. During that phase of the program, the laser was operated over 50 times, achieving lacing durations representative of actual operational engagements. These tests fully qualified the system so that it could be integrated into the actual aircraft. After completing the tests, the laboratory was dismantled, and the 747-200 fuselage was removed. Boeing completed initial modifications to a new 747-400F off the production line in 2002, culminating in its first flight on July 18, 2002, from Boeing's Wichita, Kansas facility. Ground testing of the coil resulted in its successful firing in 2004. The YAL-1 was assigned to the 417th Flight Test Squadron Airborne Laser Combined Test Force at Edwards AFB. Besides the coil, the system also included 2 kW class target illuminator lasers for target tracking. On March 15, 2007, the YAL-1 successfully fired this laser in flight, hitting its target. The target was an NC-135E Big Crow test aircraft that has been specially modified with a signboard target on its fuselage. The test validated the system's ability to track an airborne target and measure and compensate for atmospheric distortion. The next phase in the test program involved the Surrogate High-Energy Laser (SHEL), a stand-in for the coil. It demonstrated the transition from target illumination to simulated weapons firing. The coil system was installed in the aircraft and was undergoing ground testing by July 2008. In an April 6, 2009 press conference, the Secretary of Defense Robert Gates recommended the planned second ABL aircraft's cancellation. It said that the program should return to a research and development effort. The ABL program has significant affordability and technology problems, and the program's proposed operational role is highly questionable, Gates said in making the recommendation. There was a test launch off the California coast on June 6, 2009. It was anticipated that the new airborne laser aircraft could be ready for operation by 2013 after a successful test. On August 13, 2009, The first in-flight test of the YAL-1 culminated with a successful firing of the shell at an instrumented test missile. The U.S. Missile Defense Agency (MDA), on August 18, 2009, successfully fired the high-energy laser aboard the aircraft in flight for the first time. The YAL-1 took off from Edwards Air Force Base and fired its high-energy laser while flying over the California high desert. The laser was fired into an onboard calorimeter, which captured the beam and measured its power. In January 2010, the high-energy laser was used in-flight to intercept, although not destroy, a test missile alternative range target instrument (MARTI) in the boost phase of flight. On February 11, 2010, in a test at Point Mugu Naval Air Warfare Center Weapons Division C range off the central California coast, the system successfully destroyed a liquid fuel-boosting ballistic missile. Less than an hour after that first missile had been destroyed, a second missile, a solid fuel design, had, as announced by the MDA, been successfully engaged but not destroyed, and that all test criteria had been met. The MDA announcement also noted that ABL had destroyed an identical solid fuel missile in flight 8 days earlier. This test was the first time a directed energy system destroyed a ballistic missile in any flight phase. It was later reported that the first February 11 engagement required 50% less dwell time than expected to destroy the missile. The second engagement on the solid fuel missile, less than an hour later, had to be cut short before it could be destroyed because of a beam misalignment problem. In theory, an airborne laser could be used against hostile fighter aircraft, cruise missiles, or even low Earth orbit satellites, see anti-satellite weapon. However, the YAL-1 infrared target acquisition system was designed to detect the hot exhaust of TBMs in the boost phase. Satellites and other aircraft have a much lower heat signature, making them more difficult to detect. Aside from the difficulty of acquiring and tracking a different kind of target, ground targets such as armored vehicles and possibly even aircraft are not fragile enough to be damaged by a megawatt-class laser. The ABL did not burn through or disintegrate its target. It heated the missile skin, weakening it, causing failure from high-speed flight stress. The laser used chemical fuel similar to rocket propellant to generate the high laser power. Plans called for each 747 to carry enough laser fuel for about 20 shots, or perhaps as many as 40 low-power shots against fragile TBMs. To refuel the laser, YAL-1 would have to land. The aircraft itself could have been refueled in flight, which would have enabled it to stay aloft for long periods. Preliminary operational plans called for the ABL to be escorted by fighters and possibly electronic warfare aircraft. The ABL aircraft would likely have had to orbit near potential launch sites, located in hostile countries, for long periods, flying a figure-8 pattern that allows the aircraft to keep the laser aimed toward the missiles.